Something important to know for this unit is the difference between sequences and series. So just a reminder, a sequence is a list of numbers. So that'd be like 1, 2, 3, versus a series is like 1 plus 2 plus 3. So it's the sum of the sequence of numbers versus a list of numbers. So sequences converge if the list approaches a certain number. So this list would keep going bigger forever, so that would diverge. But a list like 1/2, 1/4, something that's getting smaller and smaller and closer to 0, that would be something that converges. Series have a lot of different tests that we're going to learn today to prove if they converge or diverge. Quick reminder with sequences, when we looked at these rational expressions, we used our horizontal asymptote rules. So when the degrees are the same, so like this is n1, you look at the leading coefficients and that's what the sequence is going to converge to. So we're talking sequence, not series right now. So that's if the degree on the top matches the degree on the bottom. If the degree on the bottom is greater than the degree on the top, so 2 versus a 1, then the horizontal asymptote is 0, which means our sequence is going to converge to 0. And then if the degree is greater on the top than on the bottom, then you're going to diverge. So that would be something that doesn't have a horizontal asymptote. So keeping this in mind, our first test for today is called the nth term test for divergence. So the fancy way of saying this is if the limit of an, so the sequence as n approaches infinity, does not equal 0, then the infinite series, so here's our sequence, and we're going to be like adding or listing numbers forever, and then if we're like adding them together, if that does not equal 0, then the series is going to diverge. Diverge, there we go. So the easier way to say this is if the sequence does not converge to 0, then the series is going to diverge. Series diverges. And then if the limit of a to the n as n approaches infinity equals 0, then the infinite series, so if you've got a sequence and then you start adding them up and making it a series, that may or may not converge. So that one's kind of vague. So this one could converge or it could diverge. So the easier way to say that is if the sequence does converge to 0, then the series may or may not converge. So I summed it up down here. The series might converge if the sequence converges to 0, but even then it might not. So the way, really this test is just for divergence. So we can for sure say a series diverges if the sequence does not converge to 0. If the sequence does converge to 0, then the series may or may not converge. Then we're going to have to use one of the tests we learn next to actually prove that it does converge or not. So this one is just going to prove divergence.